Now, let us define the word or the term proportion. So what is proportion? We are going to discuss the different kinds of proportion. That's why we need to define first what is proportion. So a proportion is a two ratios that are equal. So let us consider these terms or this variable a, b, c, and d as any non-zero numbers. So this variable is equivalent to any number or any non-zero. Thus, if a is to b and c is to d are two equal ratios, then that is a proportion, which is in odds notation. So we have a symbol here, a colon. That is why we have in a proportion in odds notation. Next, we have if a over b and c over d are two equal ratios, meaning the other fraction or the other ratio is just the lowest term or the equivalent ratio of the other one. So meaning this is the proportion in fractional notation. Okay, in each proportion we have four numbers, or we are calling it as a term. So as we can see, we have two ratios. So each ratio has two component or two numbers, two value, two terms. So we have 2 and 2, so we have 4. So what are those terms? So we have the A is the first term, the B is the second term. So again, we are considering A, B, C, and D as our values, any number, any zero number, any non-zero number rather. So our C is the third term and the fourth term is the D. So we classified the first and the fourth term of the proportion as extremes. So this letter A and letter D are called extremes. And the B and C, or the second and third terms of the proportion, are called means. So these are the means. So let's have example number 1. Let us determine the four terms, the means, and the extremes of this proportion. So let's have a given letter A, 5 over 25 equals to 3 over 15. So we have two ratios here, the 5 over 25 and the 3 over 15. So what is the four terms? So we have the A, which is equals to 5 for our first term. Then the B is our second term, which is 25. The C we have equals to 3. And D is equals to 15. So those are our four terms. Let's get first the means. So the means is the second and the third term. So we have the second term, which is B, equals to 25, and C, which is equals to 3. And lastly, the extremes are the first and fourth term, which is A is equals to 5 and B is equals to 15. So those are the four terms, means, and extremes of the given proportions in letter A. So next, given in this example, so again, we are going to determine the four terms, the means, and the extremes. So we have given A is to 2, 1 is to 2 rather, equals to 6 is to 12. So again, 1, when we multiply to 6, that is equal to 6, and then 2 when we multiply to 6, that is equals to 12. So this is an example of proportion. So given proportion, let's get the four terms, determine the four terms. What are the four terms? So we have A equals to 1, B equals to 2, C equals to 6, and D equals to 12. And let's determine the means. Again, the means is the second and third. So we have the second, which is 2, B is equals to 2, and C is equals to 6. So these are the second and third term. And lastly, the extremes, which are the first and the last term, which is A is equals to 1, and D, which is equals to 12. So now, let us discuss the fundamental property of proportions. So this property tells us that in any proportion, the product of the means, or the second and third, and the second and third term is equal to the product of extremes, or the first and fourth term. So if A is to B and is equals to C is to D, meaning they are in proportion, then it should be A times D equals to B times C. So A times D is a product of our extremes. So this is the first and the last term. It should be equal to the product of the second and third term, which is B times C, or the means. And in fractional notation, we have if A over B is equals to C over D, then A times D again should be equals to A multiplied by C. So the product of the term means and the extremes. Let us have examples proving this fundamental property of proportions.
We have this problem. Do the ratios 24 over 36 and 2 over 3 form a proportion? So we're going to prove if these two ratios is in the form of proportion. So how are we going to do that? So we have here the concept of the fundamental property of the proportion, wherein our A in the form of A is to B equals to C is to D. So we need to get the product of the extremes. So A times D equals to B times C. So if they are equal, then meaning these are proportion. So let's apply this property in this problem. So we have 24 over 36. So this is our A, the 24. So we have 24 multiplied. What is our D? So we have C over D, or C is to D. So we have 3. Then equals to 36 multiplied by 2, or B is times C. So 24 times 3, that is equals to 72. Then getting the product of 36 times 2, that is also equals to 72. Meaning we have 72 is equals to 72. They have same products, the mean term, the extremes rather, and the means. So we have an answer, yes. 24 is to 36 is equals, or proportion to 2 is to 3. So this is our answer. So let's have another example in proving a proportion. So we have here, show that 1.5 is to 6.5 is equals to 5 is to 1.3 is a proportion. So again, we need to use the fundamental property of proportion. So we have here A is to B and then C is to D. So our A multiplied by D, so we have 1.5 multiplied by 1.3. So we have equals to 6.5 multiplied by 5. So get the product. 1.5 times 1.3 we have equals to 1.95. Then for the means we have 6.5 multiplied by 5, that is equals to 32.5. So 1.95 is not equals to 32.5, meaning that this given is not a proportion. Why? Because the cross products of the extremes and the means is not equal. So let's solve this example 4. Solve the missing term in each of the following proportions. So we have 4 given proportions here. So A, let's have A, which is n is to 0.24 equals to 18 is to 0.2. So given the fundamental property of proportion, we need to cross multiply or get the products of our means and extremes. So they should be equal. So we have n multiplied by the fourth term or the last term, which is 0.2 equals to 0.24 multiplied by 18. So we have here 0.2n, because n multiplied by 0.2, that is 0.2n. Then 0.24 multiplied by 18, that is equals to 4.32. So to get the value of our n, so since we are looking for the missing term, which is the first term, n, divide both sides by 0.2. So to remove 0.2 here, so 0.2 over 0.2, that is equals to 1. So we have here remaining n, 1n equals to 4.32 divided by 0.2. So that is equals to 21.6. So our first term or the missing term in this proportion, n is 2.24 equals to 18 is 2.2 is equals to 21.6. Let's have letter B. We have 24 is to 9 equals to 10 is to t. So the missing value or the missing term in this proportion is the fourth term, which is t. So again, cross multiply or get the cross product of our mean and the extremes. So we have 24 first for the extremes. 24 times t equals to 9 times 10. So 24 times t, that is 24t equals to 9 times 10, that is equals to 90. So to get the value of t, divide both sides by 24. So we have 24 divided by 24, that is equals to 1. So this cancels out. We have remaining t. Then 90 divided by 24, that is equals to, when we divide it by 6. So divide both sides by both numerator and denominator by 6. So we have 15 over 4. Or in decimal, we have t is equals to 3.75. So our last term or fourth term is 3.75. Letter C, we have a proportion 8 over 14 equals to d over 91. So since it's a proportion, so let's get the fundamental property. So we have 8 multiplied by 91, then 14 multiplied by D. So we have 8 times 91, that is equals to 728, equals to 14D. So divide both sides by 14 to get the value of D here in our right sides. So 14 divided by 14, that is equals to 1. So we have remaining D. 728 over 14, that is equals to 52. So our D, or the remaining term, is equals to 52. So for the last proportion, we have given x minus 6 all over 4 equals to x plus 3 all over 5. So again, fundamental property of proportion, we can simply cross multiply or get the cross product. So we have 5 times x minus 6 equals 2, 4 multiplied by x plus 3. So we just multiply 5 to x minus 6 and then 4 to x plus 3. So let's expand this equation. We have 5 times x, we have 5x. 5 multiplied by negative 6, we have minus 30. Equals to 4 times x, that is 4x. Then 4 multiplied by 3, positive 3, that is positive 12. So let's combine similar terms. So we have 5x transpose 4x to the other side. So we'll have 4x, minus 4x rather, equals to, then we have negative 30 here. Transpose to the right side, we'll have positive 30 or 30. Then plus 12, or the remaining 12 here. So simplify, we have 5x minus 4x, we have equals to x. Then 30 plus 12, that is equals to 42. So the value of our x in this proportion is equals to 42. That's it for the fundamental property of proportion.